So let us tackle the 2019 H2 Math Paper 1 question 1. We are given a cubic function fz equals to az cubed plus bz plus cz plus d, where a, b, c, and d are real. We are also given two roots to the equation fz equals 0, mainly 2 plus I and minus 3. So our aim for this question is to find b, c, and d in terms of a. So to tackle this question, our first observation is that all the coefficients of this cubic equation are real. Hence, we can apply what we have learned, in particular the conjugate root theorem. So given that 2 plus I is a root of this equation, the conjugate 2 minus I will be a root of the equation as well. So let's write that down in our solution. So we have, since all the coefficients are real, by the conjugate root theorem, we made the observation that 2 minus I is also a root of this equation. So now we have all three roots to this cubic equation. So we can form the three factors that make up fz. So since 2 minus I is a root, we have a factor z minus 2 plus I. 2 plus I is a root, so we have a factor z minus 2 minus I. And minus 3 is a root, giving us the factor of z plus 3. So we can multiply these three factors together. We have to be a bit careful when we do this, because the coefficient of z cubed in the function fz is a. If we expand these three factors out, our coefficient of z cubed will actually just be 1. So we have to be a bit careful. To make them equal, we have to add the leading coefficient of a. So we multiply these three factors with a. So with that, we can equate this with f of z. Okay, so f of z is equals to a times the three factors. Let us expand these three factors. To expand this a bit faster, we group z minus 2 together. So for these two guys, we can use the a plus b, a minus b formula. So it gives us z minus 2 square minus I square. So a plus b, a minus b is a square minus b square. Okay, so we further proceed with our expansion. So expanding this quadratic gives us z square minus 4z plus 4. I square is minus 1, so minus minus 1 gives us plus 1. Okay, we further simplify, plus 4 plus 1 gives us plus 5. And a tedious expansion for the next step. So z squared times z is z cubed. Minus 4z times z is minus 4z squared plus 5z plus 3z squared minus 12z plus 15. So grouping them all together after our expansion is done, we have this final cubic equation. Az cubed minus az squared minus 7az plus 15a. So we can compare coefficients with what we are given. So az cubed corresponds to az cubed. So b will have to be minus a, c will have to be minus 7a, and d will have to be 15a. So rewriting what we have from our expansion, fz is az cubed minus az squared minus 7az plus 15a. Comparing coefficients gives us b equals to minus a, c equals to minus 7a, and d equals to 15a. And that answers the question.